first, we have Chandan Reddy from Amazon Science. Then we have Fanyou. He'll be discussing task 1 and 2, and he'll be talking about different practices for improving search results of e-commerce. Then we have LYZD-fintech team, and they will be talking mainly about task 2, but they'll talk about the combination of multi-language pre-trained models and CNN that they have used for task 2. If there's anyone who wants to present, please just drop a message to me in chat, or even in, just let me know and I'll add you to this. But after that, the floor is open for more presentations or solution walkthrough or discussions. Then we'll have a quick Q&A session. If you have questions for AIcrowd or for the challenge organizers, or even among yourself, we'll just have a chat, and then a feedback session, and that's it. So just a quick recap of what this challenge was about. We all know, we all use some sort of online shopping website, and often we might have realized that, we're searching for something, but we find something else, and that makes the experience a little less pleasant. So the whole purpose of this challenge was to use the power of machine learning and really harness it to elevate user experience of online shopping. And the aim of the challenge was to do this by breaking the product relevance into 4 classes: exact, substitute, complementary, and irrelevant. And that's what was the base for the 3 tasks that were part of this challenge as well. So moving forward, I'll hand over to our next speaker, Chandan Reddy.
Yeah. So my internet is not that great today, so maybe I will turn off the camera, and I assume you can hear me.
Yes, we're able to hear you.
Okay, yeah. So let me just turn off the camera, and then let me, at least, I mean, as a motivation, I mean, I think most of you know, because you have participated in the competition, the 3 problems. So firstly, we wanted to have this challenge on a large scale data, and it's not easy to collect this large scale data. It has been quite a challenge for us in the past couple of years to get annotated data. There was a lot of background work that was done during this annotation process. And finally, we felt there was a high quality data that was collected for the problem of ESCI. So essentially, ESCI is a different problem than it's a traditional search problem, where you have given a query, we have the document that is relevant or not relevant, right? But when you have product search, we cannot just have a binary classifier, because it's not a binary problem anymore, because we have different categories of relevance of the for these products, right? So it can be exact match, where the user wants to get a product and he gives a query, and there are certain products that fall into this exact match category, or it might be completely irrelevant. But there is something in between being relevant and irrelevant, that is the substitute and complementary. So this problem becomes a lot more challenging, and even for especially for the ranking case, where we have to rank order the relevant items should fall at the top of the list, and the other items that have some values, like the substitute and complementary, people do want to buy that, right? So if you want to buy an iPhone, maybe you are also looking for an iPhone charger, iPhone case, and so on and so forth. So there are a lot of things that can happen. So given all this information, we wanted to have these 3 tasks. Let me share the screen. I don't have slides per se, but I mean, most of you are aware of these 3 tasks. One is the ranking task, where you given a query and a list of products, you want to rank the list of products based on its relevance and trying to optimize for the best possible ranking. Then you have this multiple class problem, where you have different categories given a query, product, pay. You want to classify whether which class it belongs to, exact, substitute, complement, or irrelevant. And then we are interested in trying to identify a particular category, right? So it can be a substitute category or complement or irrelevant. So we are now interested in irrelevant classification. Sometimes we were interested in substitute. So we just wanted to choose one particular item. And typically this falls into slightly imbalanced, where one class has only 10% to 20% of the data, and the remaining 3 classes might have 80% of the data. So we wanted to see for one particular class how well these models perform. And in terms of the participation, we were quite happy, and with the enthusiasm shown by the participants, and it has been very positive experience for us. I mean, we learned a lot during these submissions, and of course, we are going to have this workshop where people can present this their methods. So while we see the numbers right now, we don't see the algorithms, what was done for these improvements in performance. So we have seen in some tasks over 60 methods that have performed over the baseline, and in one task I think there were almost 100 methods performing over the basic baseline method that was published in our website. So in terms of the participation, in terms of the performance, we were quite satisfied, and we are eager to know more about the details of these algorithms. Sometimes it's a massive model that may not be very friendly for production environments, but sometimes it's a very simple model with some tweaks in the tokenization and trying to understand this queries and so on. So we would like to hear more, and that is the purpose of this KDD Cup workshop, where we get an opportunity to talk to participants and some of the tweaks, and especially with what is the future for this research direction, right? So what are the, and keeping that in mind, we are going to release this entire data that was used during the competition publicly, so that moving forward, anybody who's working in product search will have this as a benchmark data set. So we had this public test set and private test set, and we have the training data. So everything clubbed together, then we are going to split it to training and test. So we have all the details. We are going to release it shortly on the GitHub repo, which is the ESCI, where the baseline code was released. And so if you are interested, I mean, I strongly encourage the participants. I mean, we are open to people who have all the methods, and just a minute. So we are interested in hearing from all the participants who are doing, who have done well. I mean, if you are above the baseline, I encourage you to do well, to submit and get feedback from this workshop. And again, there are this the schedule tentatively that was planned for the workshop on the ranking, the classification, and substitute identification. Especially, we would encourage the top 10 submissions who are the prize winners, as well as the winners of the AWS credits, to really participate and grow this community, right? And we also encourage you to participate in the community prizes, where we are yet to decide on the community prizes. We have like 4 prizes for to give for people who are going to present in the for the community challenge. Essentially, how do we help the community to grow further? How to inculcate more interest into this problem? And if you make some code available, if there are certain processing things that can help this particular problem, we are very interested to hear. And so whoever participates in building a platform to grow this research in this direction, in specific for the specific problems, we are very interested in hearing from them, right? So in terms of the deadlines, I mean, we are very flexible. I mean, at this point, I mean, we have a deadline of July 31st, but we can extend it up to August 5th if you need more time. So I strongly recommend everybody to think about submitting your algorithm, whatever your progress has been for this workshop. So saying all this, there were a couple of glitches that we found during the competition. Firstly, the first one is, as most of you know, we had given a cleaner version of the data later on in the competition. The reason being, initially we thought these tasks are independent, and we had the data split across the tasks. And then for each task, we separately split the training and test data. So in that sense, the training data of one task has some overlap with the test data of the other task. And so then we rectified it by cleaning up and releasing the cleaned version of the test data. And we ensured that we follow the same process even during the for the private test challenge. And kudos to AIcrowd platform. We really enjoyed working with them. They have done fantastic job in evaluating these submissions, in trying to help people upload their Docker files, especially during the last 1 week of the competition. And so in terms of that, we really enjoyed working with AIcrowd team. Right? And that's all what I wanted to say. And as I said, the data will be available in this link. We are in the process of making the data public. Obviously, the data is so huge that we can't upload into GitHub, but we are creating this public S3 buckets where we can share the data and upload the data and provide that link on this website. Any questions? Any feedback on the competition and the data itself? Okay. If not, I think we can move ahead, and I will stop sharing the screen.
If anyone has any questions and they are a little shy or awkward about unmuting and talking, you can drop them in the chat as well. Okay, so now that we have gotten our foundation recapped and we have gone through what the main purpose of the challenge was, I open the floor for Fanyou to present his solution.
Okay, can you hear me? I think so.
Yes, you're audible.
Okay, I will share my screen. Okay, hello everyone, I'm Fanyou and from Purdue University. So this work is mainly done by me and my friend Liu Yang. And we have three, Rado and Berich are actually my supervisor. And Xiaobo actually is Liu Yang's supervisor. So starting from 2018, we have already, annually we will participate in this KDD Cup, and every year I think we can did very good jobs. We won the champions in the 2020 KDD Cup for the reinforced learning, and we feel lucky that we can continue to do so and get a second place for the second and third task here in the 2022. Okay. I will generally introduce some graphs and explanation analysis about the data, and then I will go to briefly introduce the architecture and our milestone for this computation. So in general, our methods are quite simple. So we use a two-state method. First, we send all the query and the product to the pre-trained model, and then we conjugate all the output of vectors and send it to the linear layer, and then we get the four-class probability, and we do some feature engineering to combine the four-class probability and with the group feature or the pairwise or the product feature together, and we send it to like GBM models. Finally, we got the output specific for all the three tasks. Next, I will do some EDA for the data. In general, we have very good discovery from this data set. That might be some reason that we can still maintain the second or even have very close to the first place in the task 2. So first we find that the order of the product entries, the product catalog, is not randomized. In the task 2, it starts with the US product, then the Spanish, then the Japanese, then there is once the US ESJP and US ESJP, this sequence once again. Then we find that the last part of the data, the product ID are actually all in the public training set, and the first one of the product ID are actually in the training set. Sorry, is for the test set. So there is a part that's never unique, does not show in the training set, both in training set and the test set, and we conject that they actually from the private set. So that's a type of the data leakage here. So for the task 1, there is also this kind of sequence, but it will start with yes. So the sequence will be yes, USJP, yes, USJP, yes, USJP. So like this sequence, but still the private data set, the product ID actually are there in the product catalog. Okay, so another discover that we found that the samples, the query count, if you go to check the histogram of the query count grouped by the product count grouped by query ID, most of them are sampled with 16 and 14 products. So, and we believe that if it's a sample from 16 or sample from 14, the label distribution are slightly different. So that's why we also design some features about this kind of we call it the query account. Actually, it's called the product account grouped by query. It's a second discovery. The third one is that I think most people know that the task 1 and task 2, task 3 have different label distribution. So in this sense, if we could label each query product pair as whether it belongs to the task one, then we will have some improvement. But in the private data set, it's difficult to construct these features. I think the first place solution also mentioned that he did something like to label the query product pair in the public data set using whether this pair is in the public test set. This one is definitely doesn't work in the private situation. But we after we find this data leakage, then it's possible to construct these features. Okay, so there are some other discovery like this one. So the product ID itself is not like hashed. It's actually have a specific meaning. It's called the ASIN, Amazon identification system, like that. And also, it will be identical to the ISBN. ISBN is like to the published content. So it's like the movie, paper, book, or something else. So we also construct some features based on whether this product ID is ISBN or not, or the group of the query group has ISBN items. This one is very, the intuition towards it is that if this query recommends some books or query some movies, and this the label distribution will slightly different from to other products, right? So, and another type of feature is about brand. So most query product group have few unique brand numbers than the products numbers, which means that if you have a query have let's say 16 groups, 16 products, but maybe just there will be 3 or 4 brands, and if the products have the most frequent brands, and it tends to be labeled as exact. That's some discovery that we found. Also, this one is mentioned in the main page, is that for the task one, there is at least one product in the query products group that will be labeled as exact. So which means that and the label of the query product pair is affected by other labels in this group as well. This means that when we really do, no matter we did do task 1, task 2, or task 3, so we cannot just think about the query and the product pairs. We need to think to provide extra information about how the groups looks like. So if let's say if a query product pair has a probability like 0.4, 0.4, 0.1, 0.1, so it's labeled labeled as C, but in fact it's higher. But as the label E has a highest probability in this group, then we for some post processing we might label it as E instead of as C, right? So that's the intuition behind it. So. And next, we are going to introduce the overall architecture that we used here. So I think I just mentioned it before. So in general, because we want to attend the both 3 tasks, so we cannot train a lot of specific model for task 1, use like the construct learning or this tribulate, use tribulate loss. So we have to combine both all the data from task 1 and task 2 to train the basic NLP models, and then send it to the LYZD-GBM. So in order to make this work, we have to do some cross validation or the split the data into several folds to make the second part LYZD-GBM work, right? So here we use 2 folds because given the time limits. In fact, in the prediction submission state, we are using 4 folds. But later, when there is time limit, we have to reduce the models. So we decide to use 2 folds. But in fact, there are not many significant difference to use 2 folds or 4 folds or even more. The scores tends to be very close, so that's not a big deal. And we did a small modification to the cross encoder. The original cross encoder will just combine the query and the product, use the CLS token to split the query and the product. Then they will use a min or max or use the CLS token, the vector as a length vector and send it to the linear layer, right? But here we think that it's multi-field. They are like the title, brand, or description or bullet points. So decide to conjugate them, and send it to the linear layer, because we find that some of the products, maybe many of the products actually will have some missed description or missed title. So by using this conjugating instead of the min or CLS token, we have a certain improvement, like it's like 1%, 0.01. Yes, 1% increase in the in our offline test. Another thing is that we also for the pre-trained model, we test many of them, and finally we decide to use the DEB TRTA V3, Big Bird, and Coco LM. The interesting thing is that if we just use a pre-trained model and fine-tune our half data directly, and this one will have the best score. DEBRT V3 will have the best score. That's definitely because true, because it used like the adversarial training, this kind of or GAN types of training. So this length vector are more robust. But when we apply the knowledge destination to all those three models, we train large models and then use knowledge destination here. And the score of both three models tends to be very close. Even here, the Coco LM will have a little bit of a better performance than the DEBRT V3 and the Big Bird. But because those seed, we don't use the same seed for all the three models. So the training set are slightly different, evaluation set are not the same. So those scores are not very comparable. But that tells us if we can do some knowledge destination, then most of the models tend to be very close. The next part is about feature engineering. So based on the explanation that we find from here, E1 to E7, we design those specific features. And I think I have mentioned above. So the most interesting feature is that we're combining the E1, E2, E3 together and design features that measure the percentage of product ID in task one product list grouped by query ID. This feature gives us about 0.5% improvement in the task two public leaderboard, and it remains effective for the private test set. And that's why we are extremely close to the first place in the task two. Let's see the leaderboard. Yeah, this one is a private score, and this one is a public score. You can just see the difference. For the private score, we are about 0.0001, so 0.01 percentage, right? Difference in our score. But for the public, we have about 0.2%, about 20 times. Let's say 20 times larger difference. I think this is because the first place actually used external data, but we did not use. But we are using this kind of leakage features much better than him. We think that our construction of the leak features actually works in the private data set. Let's come back. And then there's not much to say, and we just generate the probability for generate probability from the pre-trained models, use twofold, and combine the features that we generate and put it to the LYZD model. And for different tasks, we use slightly different sample strategies. So for the task one, because the label distribution come back here, there are more S label and less E labels. So we use we centralized all the data and use the T1 data only and train LYZD-GBM classification model as well. Initially, we are using lambda rank. So we use lambda rank in the LYZD-GBM to generate the outputs directly. But later, we realized that it's not, maybe we can have another try. Then we tried just use a simple GAN, like use a GAN from the probability from the exact plus the 0.1 times the probability from the substitute and the 0.01 times the probability of complementation, and summarize them together. So this I call it expect GAN, and this one works slightly better than use the lambda rank in the LYZD-GBM. So for the task 2 and the task 3, we just combine both data and train a LYZD-GBM model. The interesting thing is that we did some analysis to guess what's the distribution of the private data set looks like, because we know there's some overlap, and the organizer actually remove some data in the public data set. The original, let's come back to check this table. In the introduction, mainly for task 2. Yes, this number is the original number of the data set in the public and the private. And later, because there's another type of straightforward data leakage, because the data shown that either task 1 or task 2. So the organizer decided to remove some of the some data. And remember this number. I will show another number here. Yes. Oh yes, it's here. So you can check that there is about 100,000 of data actually removed from the public data set, but it's just about 20,000 data removed from the private. So that's what we think, that the private data set, the label distribution of the private data set will remain like this. If we remove some part of the data from the task 1 in the task 2, and there will be about 73% E labels. So for the public data set, if you use whatever is self-destination, or just still the self-destination actually comes from the solution from the first place, or the SAM distributions data using just sample of the labels, you will have a little bit increase in the leaderboard. But finally, when you switch to the private data set, then things will change. But we feel a little bit regret. So when we actually to read the solution from the first place, we think that okay, it's gonna be possible that we will come back to first once again. but finally, still the results are very close, and that's still not that bad for us. Okay, and here we also show the milestones. So we approximately attend this computation by the 1st of July, around that time, and we do the baseline model using the simple cross encoder, and it gives us a score about 0.82, just one single model, and a single model. Then we make a modification using the conjugating instead of the mean of CLS pooling, use a mean pooling, max pooling, or the CLS lantern vector. So, and we have not significant, but still a good improvement to it. And then we switch from the single model to the two-folds. For this single model, we train the whole data set, the whole data instead of half two-folds. Then we use 2 folds, then we have a huge improvement, like 0.1% improvement. Then we think because we still have a lot of time not to use for the time limit, so we use this one should be 2 models. 2 folds means 2 models, and we times 3, and now we have 6 models. Then you can see that from 2 models to 6 models, they are not a huge improvement, right? Then just by the quite end of the first deadline is 15th. So actually we are benefit from the deadline extension, although we don't have very agree with to extend the data. No, extend with the deadline. We discover this kind of the leakage features. Before we know that there is a leakage between task 1 and task 2, task 3, but we don't know how to use it because we think the private data set, we cannot access those information. But later we will realize that the order of the product order in the public leaderboard. Then we think, okay, it's possible. So that's why we designed this feature. This gives us another 0.5% increase in the public leaderboard in task 2. And then later we think that, we realize that the group features are also important, which means that that's explanation that we found about for this the E7, E6. So we E7, at least one product in query product group will be labeled as exact, and the label of the query product pair is affected by other labels in the group as well. And we design, based on it, we design a feature. We call it a group feature. So we design several statistics that like a mean, median, and a max. Mean, median, and max actually are quartiles, right? This one is zero quartiles. This one is 50% quartile, and the maximum max is 100% quartile of the cross-encoder output probability grouped by query ID. So, and these features finally give us improvement in about 0.8% increase. That's why about 19 we are going to the top place, but finally we jumped a place to the second. Okay, this is a milestone for our submissions, specific for task 2. In our work, we mainly works on task 2, then try to generalize the results from task 2 to all the task 1, task 2, and task 3. Okay. And another thing that we want to discuss is about inference accumulation. So the organizer actually switch the time limits 3 times. Initially, the time limit is about 30 minutes, and later it will go to 90 minutes, and finally it will go to 120 minutes. So, from our opinion, this time limit time limit setting will significantly affect the solutions. So, for the 30 minutes solution, 30 minutes time limits, we are actually just use just one model. So we use knowledge destination to just have one model. At most, you can have 2 models using the DBRTA v3. And when it goes to 90 minutes, then we have the chance to have 6 models. And it's when we have 90 minutes to 120 minutes, then we can probably add some extra field. For the DBRT v3, because this model is quite large, we actually drop the description. So we don't put a description into the models. But for the Coco LM and Big Bird, because they are relatively light, so we put the description to the model as well. But it's not significant improvement. Maybe 0.01%. That's we test offline. Okay, so in order to speed up the accumulation, we did some modification or apply some other thing. The most thing that we applied the knowledge destination. So we use very standardized knowledge destination, not the self destination. So we just use trained all data and a large version of the DBRT V3, Big Bird, and CocoLM. Those knowledge destination are applied to the English contents only, not for the Spanish and Japanese. And when we read other teams' solution, we realize that we actually should put more heavy onto the Spanish and the Japanese. Maybe because we just try one model for the Spanish and the Japanese, we think that we should try something else, like what they mentioned. They mentioned that for the first and the third place, they all mentioned they use Inform XLM large. We don't realize that this one will be useful, so we actually don't use it. That's probably also another reason why we lose for this loss for this computation. Okay, and we also propose some other inference accumulation strategy. The first one we pre-process all the product token and save it as a H5 file. And second, we transfer all models to ONNX with float 16 precision. This one will be very critical because in the online system, we have a GPU is V100, right? So the V100 actually equipped with so-called tensor core. The tensor core will have larger capacity to do the inference with the FP16 precision format. That's why we transform it to FP16 precision. This one gives a huge improvement in the accumulation. For example, when we do an unoptimized model or offline, do the inference, it takes about 2 hours to just generate one prediction. But when we do this kind of transformation, and then we can predict. We can do the inference like 2 models in 40 minutes. That's a huge improvement. And I also have a discussion with some participants in the forums. Some people think that we can just have 2 models because we don't use the FP16 precision or with the ONNX like this kind of thing. And the third one is that because we pre-sort the product ID and to reduce the side impact of batch zero pending and the user relative small mini batch size. That's why we did some offline tests to check that what mini batch or the batch size is the best suit for this task. Because if you don't pre-sort the product ID and each mini batch, the sequence might be slightly larger. The length of sequence will be slightly larger. That will create the extra effort, right? Because you have to pad all the sequence in one mini batch to the one fixed size. So that's intuition that we did to reduce the inference speed, reduce the inference speed, speed up the inference. Yes. Okay, that's all of things that I want to share today. And finally, I want to make an advertisement once again. Let's come back to my solutions here. So currently I'm seeking some machine learning engineer or research scientist job in the United States. I think many people know that right now the job market in the US is quite bad. It's very hard right now even to get an interview. I have several interviews and most of them are just canceled. Okay, right, so personally I have won many champions and runner-ups for this kind of machine learning competitions. If you go to my website, so I have won several, and in total I have earned more than $100 US, maybe more than that, more than maybe 90. Okay, maybe 100, about that number of US dollars for this cash prize. And if you are interested in me, please send me the emails or go to my website directly to check more details about me. Okay, thank you so much. that's my today's presentation. I probably there'll be no questions. So I will stop share my screen. Okay. Yeah.
So I assume you're attending KDD and presenting this in the workshop, right?
Yes, I will, because I'm in the United States, right? So
yeah.
I have the chance to go to the workshop.
Okay. Yeah. You will have an opportunity to talk to a lot of people, and so it will be fun. Yeah.
Okay.
Thank you so much for that really in-depth paper presentation.
Okay, so I think there will be no question. Maybe we can have a later discussion. I will mute myself and stop the video.
Yeah, if there are any questions, please unmute yourself or drop them in the chat box. If not, we can move to the next presentation by team LYZD-fintech.
Okay, all right. My name is Yanbo Justin Wang, and we come from Longying Beijing Technology Co-Limited. And our team is namely LYZD-fintech. And then I just started my presentation. And the content is about abstract data pre-processing, model selection, model structure, trick on training, model fusion, and inference speed up. So the main goal of this competition is to establish the ranking strategy, which is divided into 3 subtasks. And I'm not going to repeat the description of that tasks. And then we just get into the data preprocessing. Since the product context has multiple fields, title, brand, etc., we use SEP token to segment the text of each field, connected it to the model input text, and use the CLS token vector as the potential feature of the data, and the input token connected as the following. For the pre-trained model selection, in order to compare the effect of the pre-trained model, we only control the difference between the pre-trained model and the classification model, and this part of the experiment. The performance of the following models on the validation side and the test side is statistically analyzed. And the 3 pre-trained models, XLM Roberta large, Infor XLM large, and Remark are selected from the following. The model structure, we use the features of the 0th token of all hidden layers output by the pre-trained model. A total of 24 feature vectors are connected into a 24 times hidden size feature matrix, and then use 3 convolution kernels with the sizes of 5 times 24, 7 times 24, and 9 times 24 respectively to extract features. After maximum polling, 1 times hidden size feature is obtained for classification. The model results of these parts are shown in the following figure. It's just showing like this. A trick on training. In order to optimize the prediction effect of a single model, we tested a variety of training techniques. Here, The XLM Roberta large model structure is uniformly used to record the performance of each trick on the validation set and the test set. According to the actual effect, we combined MLM task pre-training and pseudo-labeled trick on train the model to train the model. And a trick on training, pseudo labeling. We use the XML Roberta large model, which performs best in the first round of model selection experiments to predict the public test set data and then sort according to the maximum value of the probability vector. Find a threshold, select a part of the public test set data with high confidence as pseudo-label data, and add it to the training process of the model. In order to determine the appropriate threshold, we use the same method to sort the validation set, select 10,000 continuous predictions and slide the calculation accuracy. When the accuracy is close to the overall verification set, we calculate the average value of the maximum probability of the current region as the threshold of the segmentation verification set. Through such segmentation, pseudo tag data can be selected as much as possible, while ensuring the accuracy of pseudo tag data. And then pre-train MLM task. Using all the data of this task on the basis of the original pre-training model, the model is pre-trained again, so as to better fit the pre-training model of this task data. The pre-training is optimized only for MLM task, and the training data is constructed using 30% mask proportion. The original XLM Roberta large and Infox LM large were pre-trained, and the Rambert model was not pre-trained due to time and equipment reasons. Model fusion. Task 2, all models were trained using task 2 data, and the input was more consistent with the data distribution of task 2. So the model fusion was carried out using the weighted average method. And in task 3, the best average threshold of the validation set was used to select substitute data. The minimal probability threshold classified as substitute was set in the validation set of 3 models. And then the gradient search method was used to search with an interval of 0.001. It is used to process the probability results after the average fusion of the 3 models in the test set. Finally, the optimal average threshold was found to be 0.552. In order to get the prediction results of the 3 models within the specific time, we mainly use the 2 methods, semi-precision FP16 to make the final prediction and sort the input data according to the length of tokens, and dynamically complete the input data according to the maximum length of a single byte in data loader, so as to reduce the unnecessary computation generated by large area 0 complement pairs. Well, thank you for your listening. Thanks.
Yes, I have a question.
Okay.
So in the model architecture, you mentioned that you use 3 models, right? The robot, XLM, and another 2 models. So you actually train all the data together, right? No matter the different language. So right. So for the English, Japanese, and the Spanish, you combine together to train the model, right?
Yes.
Okay. Okay.
Yes.
So have you tried to split those language into, let's say, for English specific, you use one, maybe more robust or maybe more large models?
I think it is an idea, and maybe in the future we could have a trial of it. But I think for the model training, and so far this way is more general and more robot, I think.
Okay. We also have an observation. So in fact, when we started the competition, we decided to split all the different language to train several models for each language. But then we realized that, okay, maybe we should combine the Spanish and the Japanese, because Spanish and Japanese, although they are not exactly the same, but there might be some multi-language models, right? And then after that, we think, why not to combine both 3 languages together to train the models for the Spanish and for the Japanese. So actually in our final solutions, for the Spanish and for the Japanese, we have one model, not all of them, just one model. They are trained with all the 3 data sets. And this gives us a slight improvement. But for the English, specific for the English, this model actually does not help. So that's what I think. So instead of train the 3 models, train 3 languages, put them together into one model, probably because English, they have much more stronger models outside the world. Like in the Hugging Face, there are many models that train specific for English, right? Okay, that's what I think. So probably I'm not sure, because our experiment shows that train a model specific for English, and then train another models for Japanese and Spanish. That could be a better choice. Yes. How do you think?
I think it is a very interesting idea, and we have tried this, and this is a good idea. And also maybe some of the languages, 2 different languages, they have some connections or some relationships in I mean deep cultural aspects. So it is possibly it is a right idea. And so far we finally we just thought about, like, this is a domain specific and language independent task. That's why we just to make them all together.
But for the real production scenarios, so if we think about the real search problem, because those queries are maybe from a different website, maybe US is Amazon.com, and maybe the Japanese is Amazon.Japan. So for real product scenarios, it could split the model, right? Instead of train a single one. For the real production scenario, you can think of it. So if I'm a Japanese, so the domain know, the website or the host service know where I'm from, so they can switch to one model to another. So is it very necessary to train this multi-language version? Yeah.
Well, that depends. That depends on what you think about it, right? So I think there's not one true answer, and yeah. But I think maybe we do something more detailed to dealing with it more detailed, and that will make it more accurate, and that's the idea, and also we also need to think about the size of the samples, right? So
yes.
yeah. Well,
we
thanks.
also observe another thing that we try to train when you fine tune the models. It's not have a lot of gain if you train like more approach, right? Approach, or maybe for hours we just train like one approach for the whole data or for the half of data, and the accuracy or the performance actually remains the same. If you train more, and it's tend to overfit it a lot. So I think for our task, we actually highly rely on the quality of the pre-trained model, right?
Yes. I
right.
think
so,
pre-trained, yes, yeah, pre-trained model, yes, yeah.
So that's why we think just for this computation, maybe not for a real product scenario. So to select a better pre-trained model is critical in this task. If you don't use any external data, okay, the first place they are using some external data. How do you think?
All right, all right, yeah. Okay.
Yeah. So that's the intuition. That's why we want to split the language, because for some of language, there might be much more stronger models, right? Because we cannot train the pre-trained model ourselves. I think in your presentation, you also mentioned that you actually pre-trained your model, right? Did you? Did you pre-train the models yourself?
Pre-trained model.
Pre-train your own model.
Yes.
We also have a try, but we don't get any improvement. Maybe we are not very familiar with pre-train the model ourselves. I mean, using the text from the products and pre-train the model ourselves. Have you?
Yes.
Have you get any gain from it, from improvement when you pre-train your own model and then to fine tune it?
Well, yes, a bit improvement. Yes.
Okay, we try it once, but it doesn't give us improvement. Then we give this idea up. So yes. Okay, that's all my question. Thank you.
All
so
right.
much.
All right. Thanks. Yeah.
Thank you for that presentation. If anyone has any more questions, or maybe they would want to share their baseline with the rest of the people, the floor is yours. If there are any questions for either presentation or for the team at Amazon Science, then we can do that right now. If not, then we can just have a challenge feedback discussion. So if what would be certain things that you really liked about this challenge? What are some things that you would want to change? Either maybe it's in the structure or on AIcrowd side. What are some improvements we can make for another iteration of this challenge? Would love to hear your thoughts on it.
I'm coming back once again. Okay, I have just one suggestion: do not extend the deadline anymore.
All right. Okay.
But did you understand the fields? As I said, even though I'm actually our team, actually me, benefit from it, we still think that it's quite a torrid, not feel quite good when the deadline is approaching. Let's see, we find that there is a post about 13 or 14, just maybe 48 hours before the deadline. Now we find new news that okay, this task or this competition will be extended to 1 more week. And how do you think how will we feel? Okay.
Perhaps if Mohanty is on the call, he can maybe mention why the deadline was extended. But yeah.
Yeah,
but that's something to take note of.
That's one thing. Another thing is that from my experience, because I'm attended many competitions, right? So it's not very wise to change the rules. For me, it's a kind of like rules, whether to use the external data set, what is the time limits, those kind of things should be fixed in advance. That's my personal understanding. So when these rules are fixed, then all the participants will have their specific design for it, right? So the time limits is also very important in this task.
Right.
30 minutes, 90 minutes, very different. People all know that. Those rules should not be changes. That's from my point of view. And nothing about the deadline. Special for those top place teams like us, we are like the third place. So we think that okay, this will be 1 more week's extension. How will we feel? How will we feel? We feel very upset about it. Yes.
So so the reason that was done was because we are not only just doing the inference, but we are also running the codes. And during the running the codes process, we encountered a lot of challenges with other teams, and they couldn't put the Docker file and they weren't able to run. And so it will be unfair for them because in the initial stages, they didn't know. Many of them are really not familiar with these competitions. And so they had a lot of trouble in getting these Docker files ready in the last minute. So we thought for giving a fair shot for all the participants, we had to extend. We didn't like extending either, but at the same time, we don't want just few people who have experience to have an advantage over people who don't have experience but has good algorithms, right? That was the reason why it was extended, right?
Yeah.
And
I understand. I understand what's your perspective. I understand, but there are different people. Actually, they have different stands, right? For specific, I have to be honest. For the top teams, they don't want to extend it because the other peoples might have the chance to exceed them, right? To beat them. Okay, that's what I say in the post. I think different teams will have different views about it. But just for us, we'll feel very upset about the decision. Yeah.
Yeah.
Yes, there is one question in the chart.
By the way, before we take the question, I mean, because you participated in other competitions, is it common to get the code and run the code on the inference even before the submission deadline, or do we do that after the submission deadline is over?
Both. It's both common. It's both common.
Yeah,
but it's one thing that's not very common is that this competition encourage us to submit more because the private dataset score will be ranked based on the private data score. But this private score will be generated every time when you submit the code, right? Okay. This one is not very common. So it's different strategies. If you think that for the cargo or for some other computation, you just have to choose two or three submissions. Then the final score will be based on those two that you choose. So it will reduce. But this one will actually every time you submit code, there will be a private data score, right? So this strategy might change from my opinion.
Okay. Yeah.
Okay. There's several questions in the chart.
Yeah. There's a question from Marco Kim for you, Chandan.
Yes, I mean, absolutely. I encourage everybody to participate in the workshop. And so the workshop website and the guidelines for the submission are available at this site. So I shared that website, and as long as you are above the baseline, we will consider your submission. If you are in the top 10, you are guaranteed to have a workshop slot for oral or poster presentation, depending on the number of submissions. And for top 3, I strongly recommend you being there because you will get to take the prizes in the banquet, and it will be a very good visibility for the teams. And so I encourage you to participate in the workshop and submit your paper. And we will try to publicize this as much as possible. But I mean, this is only for participants who has scored above the baseline, right? So this is a very small group of people who are going to be who focused and who know about the data and all the aspects of the challenge, right? So you can go over it, right? So there was another question, right? Was there a specific reason on splitting training and test on the queries? So that same queries aren't, yeah, I mean, just to ensure that generalization. So one thing is we are going to release the data, entire data, and at that for that data, we don't have public and private. We just are going to split into train and test. And we are going to upload the data, and we want your feedback in the initial stages. If we will make sure there is no data leakage, we will carefully do the splits. And that was the reason we want to make sure that it is generalizable to unseen queries and product pairs, right? And is there a way to participate in KDD Cup workshop? Yeah, I mean, that is a very tricky thing because many of the workshops and tutorials, the organizers this time in KDD Cup, they're in the KDD in general are very strict about having in-person participation. But we understand for KDD Cup, I mean, if the winner is in outside of US and he cannot come for genuine reasons, we will still encourage you to submit the paper and have a video presentation. We may or may not play it in the workshop, because of the time constraints, and if there are more in-person people, we would want to have that from them. But we will definitely post your PDF and the video on the workshop website, especially if you are in the top 10 submissions. So if you are in the top 10, it will be very good for you to gain more visibility if you write the paper. And even the paper can be just 2-page or 3-page. It doesn't have to be a complete 4-page, as long as you can convey your algorithm, your ideas, and what you have done and how you performed. That's more than enough for. So don't worry about the entire being very professional. And we wanted to keep it open. And so that's why we said we don't want to have a proceedings for now. And we are going to just make it open for people who are not hardcore deep learning researchers, for example, right? And they have a lot of tweaks that got them to be in the top 10, and we encourage them to write some kind of a draft that explains their algorithm and the code, and present it as a video. And we will definitely post that video in the workshop website, right? And so that is about, if you are not, especially if you are not in the US and you can't travel, you are strongly recommended to post a video and just have like a 2-page or a 3-page paper, and we will post it on the website.
Chandan, so
Yes.
I've just asked, thanks for answering the questions. So to clear up, there won't be any live, like an online session to connect with people who are not in the US, but people outside the US are encouraged to submit papers and like a recorded video file so that you could present it if there is time available.
Yeah, so I don't want to promise anything. We will try our best. And this is only for top 10 submissions, what I'm going to say, right? For top 3, I mean, we will try our best to, because it depends on the conference team as well. If they will be able to provide us with this live sessions, and it's more than a Zoom call at that point, right? Because we have to display it in the larger screen. And so the idea is that the conference team is not very enthusiastic about having a lot of live video demos, because people who are over there in person might lose interest, right, compared to having a live presentation. So although we want to hear from the top 10 submissions for each of the tasks, I cannot promise that it will be presented as a live demo. But for a video presentation, definitely, for sure, right? I think that we can make it possible. At least we will have it in the workshop website, and if there is time, we will definitely put it in, especially if you are in the top 10 submissions. We will play it in the conference. But for a live session, I don't want to promise. We will try our best. That I can promise, right? But it is beyond our, because this is held by workshop chairs and the conference chairs and the general chairs. So it's much beyond my ability to make that happen.
Okay, thanks for the answers.
Yeah.
If we don't have, this is just a reminder for the community contribution prize. The entries are accepted till 31st. So please make sure you submit. We have really good prizes for this. Yeah, so if there are no more questions, I think this is the end of Town Hall, unless someone wants to share a closing remark.
Firstly, I want to thank everybody for working hard in the competition and doing extremely well. We were very happy about the enthusiasm shown in the competition. and we can keep working on this data. We will share it publicly, and I hope this will increase the enthusiasm in this problem of product search. And I really appreciate this will be the first effort essentially, and once the data is public, I mean, many people can use external data sources and try to improve the performance. And this, to me, I see this as a starting point for a lot of future research in this area. Especially, I think that I consider this to be ImageNet for product search. I mean, it's a huge data set. It's not easy to get these annotations. These were systematically annotated. And so I do see a growing group of researchers who will want to work with on this problem space. Okay, so thank you, and thanks Neha for organizing this community town hall, and thanks for the presenters.
Thank you everyone
especially
for attending. Yeah. Great.
Yeah,
I'll be sharing the link for this session soon. Thank you everyone. Have a great weekend.